In this example, we are going to find the derivative of f, and then we're going to evaluate the derivative at x equals 3. For this function, f of x, we have to use the product rule because we have the product of multiple functions here. However, this is going to be a little bit tricky because we actually have 3 functions here. And you can label it however you want, but I'm going to label this here as my first function. So 2x sine x is going to be h, and then I have cosine x as my g. Now, the thing that makes this tricky is if you notice, within h, I have 2 more functions. So I'm going to call this h1. So h1 is 2x, and h2, that's sine x. So within h, I'm going to have to use the product rule a second time. So let's look at this a little bit more closely. When I take the derivative using the product rule, so if I look at it in just terms of h and g to start off with, and then we'll break it down further. The product rule says I take the derivative of h times g, and then I want to add that to the derivative of g times h. Now, we're going to break this down again because the derivative of h itself is another product rule where we have functions h1 and h2. So when I look at h prime for the derivative of h, within that I have to do the derivative of h is the derivative of h1 prime times h2 plus the derivative of h2 times h1. So this is my product rule for h prime. Then I have to multiply by g and then add g prime times h. So it's this right here that makes it complicated because you have a product rule within a product rule. But if you write it out step by step and take your time, it's not as bad as it looks. So let's actually work it out now. I need to take the derivative of our h1. The derivative of our h1 is 2x. So the derivative of h1 is 2. So that's going to go here. And then I'm multiplying that by h2, which is sine x. And then I'm going to add that to the derivative of h2, which is cosine x, times h1, which is 2x. So this big mess right here is the h1 prime h2 plus h2 prime h1. That's a mouthful. Okay, I still have to multiply by g. That's this right here. When I multiply that by g, g is cosine x, so I have cosine x. Now I have to take the derivative of g. The derivative of g is negative sine x. And then multiply that by h, which we said was 2x sine x. So let's look back again. This whole thing right here is my derivative of h, which we broke down using the product rule within that. This is my g. This is my g prime. And then this is my h. So I have, when I find the derivative of f, it's the derivative of h times g plus the derivative of g times h. Now, when we clean this up, I'm going to distribute, I'm going to distribute this cosine x to the inside of this parentheses. So I'm going to take 2 sine x times cosine x. That's going to be 2 sine x cosine x. Then I'm going to distribute the cosine x to the cosine x 2x. So that's going to give me a plus 2x cosine squared x. Now I'm going to multiply these, and I'm going to get a minus 2x sine squared x. Other than factoring out a 2 from everything, it doesn't look like there's anything else you can really do, so let's leave it like that. Now we're going to evaluate this at x equals 3. And again, if you look up here, this 3 doesn't have a degree symbol there, so we're going to make sure our calculator is in radians. So everywhere I see x, I'm going to plug in 3. And when you round that to 4 decimal places, the directions, although I didn't write them down here, let me write them down here. The directions in the question says round to 4 decimal places where possible. When you put this in on your calculator and you round it to 4 decimal places, you should get 5.4816. And I can't stress this enough, because this 3 didn't have a degree sign, you gotta make sure your calculator is in radians when you plug that in.